All right, good morning, everybody. Today is the CAPN office hours. Happy New Year, as we were just chatting about, since this is the first one since the new year. Hope everyone had a great holiday, got to spend some time, and excited for the rest of the holidays this year. We only have one thing on the agenda. I know I also have an item that I'm just picking up, and I'll be probably sending some pull requests over to you, Faye, or Charles to approve, since it's going to be about image building, getting all of the VC images built. I'm going to need somebody from the approvers list on those to help me out with just approving. I can go to Vince as well if you all are busy. But wanted to turn it over because the one item that we do have on the agenda was an open issue that Wei filed a couple weeks back, week and a half back, to kind of talk about. I'll let you take it over, actually, Wei.
Yeah, so thanks for the answers from Chris and Faye. I just read the answer from Faye that he think quota management should be done in the webhook, and the syncer is a place where only the state sync should take place. So I totally find it's okay to to have this kind of design, but in reality, we had an in-house kind of a quota management, and we do implement in the webhook and in somehow, but it's not related to the virtual cluster stuff with other things. And this also some collaboration with the Ali folks in other group.
Could be Q. I know.
Yeah. We have a meeting yesterday evening. So, but this is the kind of a open source stuff that we still ongoing, but much earlier than that, we had other discussion about that, and we put in webhook, and Ali folks also put in webhook. But this is okay, but this also give us a lot of headache by putting in a webhook, is that we have to serialize all the operations, and we have to kind of get a atomic operation to check the quota and do the decision, and if the pod get created or not, when we have to reverse some of the logics. So there's an operation that not easily can be done in the webhook, especially given that we have a syncer in place. So imagine that we have a syncer, need to check the quota. The same time we use a webhook in the supercluster, then we got asynchronous response from different components. Then end up we probably need to do a much bigger locker to do the operation to make sure that no other user is getting the quota and check or adding more quotas in to make things get much complicated. But the syncer itself is really kind of a serialized operation at this moment, the link between the virtual cluster and the supercluster. It's really a good spot for us to do end-to-end control, because in the syncer, we can check everything before launching the P pod to create in the supercluster, and all these things is totally under control. So this gives a very sweet spot for us to do a lot of things there in the future, and do some extended logic for user to put things in the syncer place that we seem that it's much efficient. I personally did some implementation and try a little bit, see how it works, but I think the code is much easier compared to the previous code we did with a webhook, and we can implement a lot of things and serialize some of the tenants. Only thing that's unfortunate that is that we cannot currently make per tenant queue for the virtual cluster, because the design is per controller per queue, and we have multiple workers to dequeue the operation. So there's no way we can really serialize per tenant operation than in the syncer. But syncer is kind of a place that aggregate all the requests, and we just separate by the type and the kind to make the queue separation. But if a tenant is really busy, they can end up occupy all the queues for one for one
I think
time, correct?
I think we have fair queuing. Although I understand it's per.
Yeah, fair queuing is it's fair queuing. True, you have the rate limiting there. I read the code. So you put the rate limiting. You think it's yeah, it's fine, but
It's not rate limited. It's not rate limited. It's round robin.
round robin, and you also rate limiting to prevent some noisy neighbors, correct?
No, I don't think we have. I mean,
You have.
the rate limiting. I'm using the standard controller rate limiting, so you can set
Yeah.
the rate limit of the controller. But our QoS is round robin in the sense that none of the. I mean, if you have a lot of things, you are gonna penalize. So it's round robin. So if you send a lot, if one tenant send a lot of requests, that tenant is going to get not exactly throttled, but it won't perturb others because others will have a chance to go. There's no starvation because we use round robin. It's weighted round robin. So so that is the way that we provide fairness. Well, the other things is if one thing keep flooding with requests, they may flood the API server, but this is something else. You can do you can do the rate limiting in the API server. Basically, you want to control everything that tenants control. But fairness, I think we can provide.
Yeah, I think this is okay.
We don't have a knob to control every request from one tenant because it's considering queue based. So we can only control the part is fair. The service is fair, but we don't have anything that combines the tenant scope. That I agree.
Okay, yeah, this is the even bigger things we can discuss later, but put in some plugin or things in the virtual thinker. I'm not sure we want to try something there. It's still very early.
But
I can put
my opinion is okay. So here's my takeaway. So you can do whatever you want. You fork it, you do whatever you want. That's perfectly fine. But if you want to make it as a plugin, the difficulty is that think about it. So it's not a simple plugin. You have to any people wants to add a plugin to do something that you were mentioned, he needs to introduce a CRD. Most likely.
Yeah. We did, for example. Yeah,
we did.
You definitely have to use CRD because whatever you do is not a standard.
But we're not exposing it at the tenant control plane level. So this is where it gets a little bit interesting.
I know.
It's only at the super. Yeah.
The syncer needs to work with other CRDs. If you want to make it a plugin, that plugin definitely need to come with a CRD. So it's not very easy to make it as a plugin, very generous interface to support both logic and CRDs.
No, I mean that the plugin is that just before for example, what I implemented that just because before the P creation happening in the reconcile.
I'm saying that CRD needs to read your quota. That quota is a CRD.
Yeah.
So which means the syncer needs to work with other CRDs. I mean, right?
Yeah, we already have that set up. That's some of the work that we did originally when we forked it so we could support, because we have one CRD that our tenant control planes expose. So we already do have it configured so we can have a dynamic client down to the supercluster, and we can leverage that to basically inject the scheme and then use that to like sync our current CRDs that we actually have from tenant to super. So on top of that, we also have that same dynamic client can be used to grab the quota controller or the quota management.
So let me ask you this. So it's kind of purely dependent. So if you say each tenant need to have a quota, right? Where do you specify the quota? Do you specify the quota in a CRD in the supermaster?
Yes.
In the supercluster? Yeah. So then the syncer needs to know that CRD, right?
No, the just this validation logic need to import the CRD information and get a client to interact with this CRD.
Yeah, exactly.
But the syncer itself, from the community syncer standpoint, they do not need to have dependency on this CRD.
Yeah,
the dependency is only income.
So what I'm saying that you want to make it as a plugin, as an extension. So you want to generalize the interface. So that the generalized interface needs to support CRD.
No. I just need a general interface and give a hook there, and dynamically, if I need something, I just at the runtime after startup, I register this plugin, and in the same place in your pod syncer can call this validation general interface, and how the interface work is totally out of picture of your the community code. As I think Chris gives a little example of how we register these things in their answers.
So a perfect example of this would be, we don't technically need to, you don't need to do anything special to make it so that the syncer knows about the CRDs in the supercluster, because we already have a controller runtime dynamic client created. So it already has, as long as you pass in the scheme, when you have a fork of this, as long as you already have a fork of this in the MC controller, there's two clients. There's like the base, there's the base client that's like raw client go, but then we also have the dynamic client that connects back to the supercluster. So we have an easy client to basically access all of the any dynamically registered resource. So we actually can basically pass the MC controller into the plugin and then do get delegated client on there to make any operations that we need to do that are outside of the scope of like the typical informers that we have caches for.
Is dynamic client is unstructured, right? It's unstructured, right? No,
it's structured. It uses structured types, but it behind the scenes, it's all controller runtime, so it does all the conversion for you. And so you can basically use like raw, if we say, for instance, our resource is called virtual cluster quota. The virtual cluster quota CRD, we just use the raw type and pass it into get, create, list, so on and so forth. And then we don't have to actually, it just returns us back client.objects that we can then make any calls on.
Yeah, but I need to refresh my mind. But a dynamic client, how do they get the GKV if you don't specify it? So because of every single resource being registered with the scheme, they can basically call get group, get version, get kind off of that, and that's how they format the request for these things. And in essence, this is just the dynamic clients are just doing the JSON serialization using the JSON object, like the Go types, to serialize and then calling off of. But you have two versions. Which version we're going to pick? You have a beta version. You have alpha version for the same kind.
Whatever you've registered. So in those in the registration,
you need to register it. Yeah.
Yeah. In the scheme, you're registering what types you're going to use from that standpoint. And then if you register two API types, there's typically a conversion func between the two of those, so that it will do the conversion on the local half before sending across.
Yeah.
And also from the side,
Go
ahead, Wei.
Yeah, it's all done. I can put some rough code there somewhere.
Yeah, but just tell me what's the difference if a dynamic client can do this. So yeah, just tell me what is the drawback of doing this. So why not everybody use dynamic client?
There really isn't one. At this point, there was at the beginning. Like controller runtime at one point was a little bit slower because it had to do all of the configuration around this. But now that everything is using, everything under the hood is either using runtime.object or client.object, which is a mirror of runtime.object, it's all relatively the same performance-wise. So there's really no drawbacks of actually using dynamic client, which is why you see a lot of non-core controllers using controller runtime for this. I mean, it's also the same thing that they changed the base implementation underneath the like operator SDK to use these things. So
yeah, but good to know, because we haven't used it. I mean,
oh, it's a great tool. It drastically reduces
the
amount of boilerplate that we end up having to write. So like all the informer caches and all of that stuff that we usually go and configure and have everything like hard coded, all of our add, delete, and update funcs, all of that can get like all of that boilerplate can pretty much go away, and we can just use like the controller runtime client, and there's just a watch func, and then you basically reconcile based on events that come through a watch func. It's a pretty clean interface. I think we did a demo.
Is this 3.0 or later or just before?
This has been around since at least 2. I know I was using this with at least key. I need to check versions on what I'm saying here actually. Because all of these things have been in place for at least 2 years. We had I think last year, if you remember correctly, and we can always go through the videos or like the YouTubes, but like at one point Vince came and did a presentation on env test as well as controller runtime clients, All of that stuff is pretty much what we're talking about.
Yeah,
I think that was,
I probably missed that one because that's okay. Good to know.
it's a
good.
it's a really, really solid piece of code to basically go use controller runtime for this. I have had multiple branches where I've tried to go through and change out the syncer. There's so many pieces to the syncer that just makes it really difficult to do, but I've definitely gone through and started this migration to try and move us over to that, because it's like a very standard client, and we could strip down to just one single client and have it so that you can inject schemes and all that stuff. But
Yeah.
I think that's a task for
Much.
this year to really go through and finalize.
Yeah.
Yeah.
If we can move this one, and a lot of kind of our informer, different type of informer can be consolidated to just one client and use it per on demand. But this is so at least there's no dependency involved here. All things I need to is that just a clean generic interface.
Yeah. I've at least seen what Wei's been doing from the internal side of things. Like the interface is basically very similar to the registration func that you have for the current resource syncers. We'd obviously have to do that. Yeah, exactly. Yeah. And so we were able to leverage a lot of that code. I think the big piece is there's two parts to it as well. And correct me if I'm wrong here, Wei, but there's like we need the plugin. Then there's also some code already in CapN that just never got finished. I think there's like a whole like new way of doing conversions with objects. I've noticed. I think Jerry did some of this work, but basically like there's now a place that we can inject mutator funcs onto different types of objects. I'm not sure. If you have any context on that, that would be fantastic to see if anybody can help pick up that so we can finish that, because we need to be able to mutate pod specs based on whatever the whatever comes out of the quota, whatever this plugin looks like. And then on top of that, we need the plugin implementation so we can have the validation function. And then on top of that, and this is, I think, the other piece that we haven't done internally yet, correct me if I'm wrong, Wei, inside of there, we need to basically configure an additional flag that stops the syncer from trying to sync resources with some type of attribute. So right now we have like the I forgot what the actual function was that we have in there, but there's basically one single binary binary function that basically will return whether the pod is ready to be synced. And we want to basically add an additional field to that we could potentially supply through like a CLI flag that says, if this pod has this label, or if a pod has this label, or any resource has this label, don't add it into the queue at all.
Yeah. So this we can reduce some, especially the batch kind of a large operation, that if they fail to launch, and we're not go back to the same queue and get reconciled every patrol time period. At least we wait until some kind of big quota get released, and we think it's good, then we put back to the reconcile queue, then we can do it.
But I don't ask, can you explain the use case again?
Yeah, so in some case, like batch job, they launch thousands of pod in time.
Yeah.
So in case that we have one round of detection that this pod cannot be scheduled or cannot be synced due to resource limitation, then this pod will not be immediately go back to the same queue it was. Instead, we put a new label there and sitting outside your queue. And
so
we will have.
So I'm assuming the queue controller installed in the VC, right? Not in the super. Where is the queue controller installed?
Yes, it'll be installed in the tenant control plane.
Yeah, tenant control plane.
So
the idea there.
Tell me the logic of the rig.
No. The logic is that we put a label there. If your reconcile see this label, it won't go through all the reconcile logic currently we did for a standard pod. So we at the very beginning, this pod gets either spin off the queue or put back to the queue. At least we have a small label just to skip all the heavy logic. Then when we think it's time to put back, then we get another logic spin outside your syncer, then we can remove this label, then this will go through the normal process. This is a little bit performance kind of enhancement that in case there's quite some pod gets stuck in the pending state, then cannot be scheduled due to a quota, then we put some enhancement there.
But you need to really think about this. I know the queue things, so but you kind of violate, not exactly violated, but we need to think about it. So it's like you are putting the scheduling logic in the tenant control plan. So
not really, but this just to optimize a little bit the queue that normally the things get back to the queue immediately and get reprocessed, which is a pretty expensive and waste. So we try to get the secondary queue that for this kind of a pending pod, so that it was be organized in such a way that when the quota available.
I think queue, it depends. So whether that queue needs to know the scheduling results. But based on my understanding, it will know. So
let me try and give a little bit of the use case. So one of the things that we're trying to do is basically we want to make it so that the tenant control plane can still use resource quotas separate. So we don't want to basically gate everything on resource quotas. So we don't want to actually leverage that resource as the object that protects from somebody from being able to overload their own control plane. With that, the experience that we're basically looking for here is something that can stop pods from syncing down to the supercluster, but doesn't lock up the syncer from being able to continue syncing pods to other tenant control planes. Because where we get into a place where, like, if you think about a standard Kubernetes distribution on, like, say for instance, EKS, you provision a bunch of nodes, the scheduler or the API server doesn't stop you from creating pods against a standard Kubernetes cluster. If all of the nodes are out of quota, you just get pods and pending. And so that's kind of the implementation that we're in essence mirroring. So we want it so that somebody could just fill up the API server with as many pods as they want, and it schedules whatever can fit into that capacity. And then as things go through and either we trigger like auto scaling on that quota so that it can fit the needs and then scale back down, or on top of that, having it so that we could have, as jobs stop, other jobs can take their place, or other pods can take their place. And so that's in essence what we're trying to do. And I think why we can't do a webhook at the supercluster.
But I think you have, so yeah, I mean, I totally agree. So think about it in tail the link, right? You have so many places you can stop it.
Yeah,
you can stop it in the tenant using a tenant webhook. You can do,
except for a tenant webhook can so the problem with that is that you can't register webhooks outside of the actual Cube API server. So any webhook we inject into the Cube API server at the tenant level, they can go and delete. There's no way to supply like admission webhooks via CLI flag, or via like API server flags, which is so annoying.
I see. But the supercluster webhook definitely can also do the thing.
Won't that lock up the entire queue? So say for instance, somebody created 50,000 pods, they only had quota for 2, and it basically is just sitting there trying to recreate for all of those pods from that single cluster.
We have a failure limit. It won't forever, right? I think.
If that's, well, you're probably right. Well, if we don't have rate limiting on the queue, we probably don't then. Because if it's just round robin, maybe we could check into that.
Well, it will burn a queue, no doubt. Yes.
Yeah.
It will burn. If you put 10,000 in an API server, that you have 10,000 objects in that queue, but round robin definitely should work. So because because
it'll continue to go through.
It won't block others, I'm pretty sure, because we will give a dedicated queue for each tenant per pod. It's dedicated.
You have a dedicated queue for each tenant per pod?
Yes. Check the code. Yes. It's not exposed. It's not exposed. It's like we have a bigger queue, drain everything, but before we out of queue, we implement the parallel multiple queues. Each queue is for each tenant. So we do the round robin for that small sub queues.
Okay.
All right.
Yeah.
So then maybe we do have the ability to do this. I wonder if that means that we could potentially inject. Is there ways that we could? Okay. All right. We're gonna have to look more into that then.
We can look at this.
The design is we have a single entry point. Everybody drop it, but the out queue is not direct output. The out queue is after you in queue a big entry point, single entry point, then you spread the object to per tenant queues.
Okay.
Then we do the round robin for out. The
Okay.
D queue is definitely round robin. The in queue is mixed.
Okay. Okay. I maybe not read the code carefully. Let me go back to see it. I didn't see the tenant per tenant stuff in the Captain.
No, it's within that fair queuing implementation. It's very specific for that fair queue implementation. Just check that code.
Okay, let me go ahead.
So in that we have, I think we have a per tenant sub queue. It's not a per tenant queue, it's per tenant sub queue.
That's why we have the fair queue and the FIFO queues. Is it basically the fair queue is leveraging FIFO queues as the under?
For in queue and D queue, but within the logic is a fair queue.
Gotcha.
Yeah.
Okay. Yeah. Let's give that a bigger, a deeper look then.
In fairness, you don't need to worry too much, but I do understand your concern. So nobody wants to flood. I mean, that is really concern when I designed it. There's no way I can stop people to doing that. But I think we can tolerate that anyway. It won't make things crash. I'm pretty sure it's just burn memory. So you need to do whatever kind of things in the tenant side to prevent it from happening. But I doubt you do it in the sinker doesn't solve the problem, because again, that informer will get all 10,000 parts.
The idea there was basically a secondary queue that's going through and re-reconciling those things and going and so we would dequeue by adding a label, and the pod informer would only pull from a queue with a specific or without that label on it. And then if it doesn't match, if it doesn't meet the validation criteria, for example, we can go and label that pod in the tenant control plane, or set a condition or however we want to actually do that.
That flag is okay. I mean, that hack I'm totally fine. If you want to add a special label for doing this, I'm okay. But who is going to do the logic in the tenant? Who is going to do the logic?
For us, it's basic for our implementation.
For setting that flag saying don't sync it.
For our logic, it's built into the validation plugin. So if it fails, it sets that label, and then it sets that label in the tenant control plane, and then there's a separate queue that's like the quota queue that basically lists all pods that have that label and dequeues them, or not dequeues them, takes off the label so that it can go and repopulate back into the pod queue.
So okay, first thing is validation webhook. Where it is in the supercluster?
Right now it's in the sinker. Right now, and what we've done internally right now is the pod has it on the pod creation sinker. On the reconcile create pod create.
Okay, secondly, who is going to remove that flag?
There's a secondary sinker in our internal implementation that goes and removes that flag. None of this code, by the way, has to be pushed upstream. It's really just the interfaces that we need to be able to inject the validation plugin, and then also the informer filtering label. Those are like the real changes that we need upstream to be able to do this. But we can definitely show what it would look like, so that you can see kind of the implementation if you're interested.
Yeah, my personal takeaway is adding a flag saying don't sync it. I mean, it's okay. Just define an API. You want to have a label for that? That's perfectly fine, because that is simple interface, because whether who set it, who unset it is out of, so you can do whatever you want. But yeah, but valid. I'm still kind of not exactly sure adding the validation in the sync is a good idea.
Okay.
I mean, because
technically, I mean, what you're saying would work if we do it if we do a webhook at the supercluster that does the verification of this. But if that fails, we need something to
because we need to understand the goals, right? Exactly. So what things you want to optimize? So what do you want to save? So everything that you've done, you cannot save the sinker's cost, because sinker, as long as you have put something in the the tenant control plan, syncer needs the informer get that objects. It will burn the memory for the syncer for sure. What I'm guessing is you want to save the objects in the super. Is this the intention?
Don't want them to go to the super. If there's not capacity, don't sync them down to the super.
Oh.
Yeah, this is all keeping the virtual as a
So that we
pending
basically,
state.
yeah. So that we don't flood the super with memory issues by having pods that aren't able to be scheduled. So we wanted to keep that outside of the super. Our implementation was to push that to the syncer so that it stops it there.
But if I give you a flex that don't sync, so can the queue controller support this? So you want to be purely transparent. I kind of understand, but anyway, I don't know.
So I don't fully know all of the context around the queue controller because that's kind of being treated as that's a little bit of a separate project.
You want to make, I mean, it's all the, I don't know. So if I want to
tell us your thoughts. What are you thinking there? Yeah, I mean, what like
if I were doing this, I'm going to talk with the queue guys. So
which queue guys?
What if this is needed for outside of the queue? Ignore the queue entirely. Like that's another project at Apple that would like just ignore that entirely in terms.
Yeah, this is other things. Yeah.
Yeah.
This is totally not integrate with us yet, and they are also in the other community to talk.
Then let me ask you this. So in Kubernetes, how do you prevent people create 10,000 pods?
There's no way.
Resource quotas. It's the only way.
Exactly.
Yeah.
So
the problem is we want to give control to the tenants for the resource quotas. So imagine we have, large clusters and we're trying to do, yeah, exactly. So this is where it gets weird. We want to still gate what an entire cluster could use, an entire virtual cluster could use, but allow them to scope resource quotas however they want. You and I have chatted about this before. Like I don't want, so at the lowest level, what our objects are that we pay attention to are the quota that is actually being used from pods, not resource quotas themselves in the tenant control planes. And so say, for instance, any team could go and create an entire platform on top of this and scope out their resource quotas in their control plane however they want based on their business needs.
Okay, but they still need a per tenant quota, right? That is something you guys provide, right? You need
exactly, and that's the clusters. So that's multi namespace quota that we're talking about there.
Okay, I agree. So you can do, I mean.
So the implementation that we have, I mean, just to talk about it, because it's not super special. It's like the implementation we have in the validation plugin, and Wei, correct me where I'm wrong, is basically we use resource quotas in the super that we sync down, that we create, so it can do the aggregation of all of the namespace or all of the resources that are synced to the super cluster, and then we use in essence all of the aggregate quota that's added that's in each resource quota in every single namespace and aggregate that up to basically do the verification of can a pod sync. And so we basically have anytime a namespace gets created in the supercluster from the syncer, we go and create a blank resource quota object. Then every time a pod gets synced, the admission controller in the supercluster will go and add the used quota to the resource quota object that's backing it. And then every time a pod gets synced down from the sync, or every time a pod is trying to be synced, we go and grab all of the namespaces that are associated with that cluster, with that virtual cluster, and grab all of the resource quotas that are associated with it, aggregate all of the quota, just like the typical admission controller does, but instead of adding up all pods, we're adding up resource quotas, and then we add on the pods, the current syncing pods resource quota usage to verify it that doesn't go outside of the bounds. So that's our way of multi-tiered aggregation of quota, so we can verify if the supercluster can handle it.
Okay. I'm not saying that you're not doing the right thing. So, I'm just saying that doing the sync may feel, I mean, the entire logic may look simpler, but think about what exactly you guys trying to do, right? You are doing the you are called a check logic, you are trying to do something like API server does, right? So you need to make sure that part is actually created before you can. I mean, otherwise.
Yeah, this is where the special logic need to make the things here.
You need to keep the states. You need to, so wherever you want to do the check, you need to keep the states. I'm not saying that you cannot do that.
Yeah, we do keep state. This is the best place because in the syncer is serialized. So this is a synchronized operation that we check the validation, we do the P pod creation, and we know the P pod got created or not created, for what reason not created. So then we can update something there. This is all synchronized or serialized. On the contrary, on the webhook, there's an asynchronous operation.
You don't know if the P pod, I mean, okay.
The thing that we don't know the P pod got scheduled or not, but at least got created means that the admission controller is already counting the quota in. So this way, we don't care because as long as capacity being consumed, maybe there's in the later stage that cannot be scheduled. It's not our problem anymore. So this is the thing that we are not guaranteed scheduled, but we guaranteed it was registered in the admission controller that the quota has been used.
But what if your DWS has multiple reconcilers? It's parallel, you are doing parallel creation.
No, we try not. We have to put the lock there per tenant lock to make sure. Yeah.
The other thing that I mean, at the end of the day, if you look at the way that the admission control works in the Q API server for quota management, it's the same exact problem that they have. Like there's, say for instance, you have 5 replicas, there could be 5 all having resource contention on the same resource quota object. So in essence, what we're gonna long-term do is be using the virtual cluster quota object, like the CRD that we have, to mutate that to basically manage whether it's actually, whether it's,
I don't think
whether
you put a DW, I mean, hope you are not using single lock to lock the DWS, but I don't think that's a good idea to lock. So especially in upstream code. So if only one guy's need queue, the other guys doesn't care about it. But you make everything just serialized. Is that a good thing?
So this is why if we can serialize only one tenant, currently we create a lock for per tenant. So one tenant is get serialized, not serialize other tenants' job. So each virtual class has a one single lock to lock
Really?
kind of thing.
Where do you put the lock?
I already implement our in logic there. We can do a lock anyway by the mapping the key, which is a tenant ID.
Oh, God, so for
But
tenant,
as you
we
said,
only have a VC object. We don't have a struct for that. You need to keep maintain all the life cycles for the per tenant lock. So I don't think that's very easy. I mean, you can do it definitely, but I don't think that's a very neat thing to do.
okay.
In sync implement per tenant lock, I don't think it's a good idea because it's like you need to put a lot of very careful logic for that.
Why?
Because tenants go away, just come in, go away. You need to make sure, right? It's just come in and come out. So you need to make sure that you need to have a struct to hold that locks.
Okay, I will put this in mind. Yeah. Okay.
Keep the life cycle. Think about the life cycle. So.
Okay. Yeah.
That's probably okay. I mean, it's doable. It's definitely doable.
Yeah, your currently implementation is quite simple as long as it's deferred unlock, and if the cannot go away, we just need to clean it. Yeah, we can clean up a little bit the maps. Is there
you had a log in the class set. I think we have a structure, so just I take it back.
Okay, but I just I just double check your fair queue logic. I think the output queue is per group, item group. So I don't see the per tenant. Still, the queue group is a. Are you talking about queue group? Correct? You have a queue group. You have a key, a map key to map different groups.
I think that is the per tenant.
No, it's a per group item.
One group with one tenant, if I understand correctly.
I think one tenant is one object type, which is this group is a tied with the object. Okay, maybe I'm wrong. Maybe I think the item.group, which is yeah, it says tenant, then it's much better. Then we can do something there.
It has to. I mean, this is about 2 years ago. The code. I need to go back and check.
Oh, okay. Let me double check. I think your object, you basically the key is extra from your object. So the object should not contain any tenant information there. It only contains type information.
It has a class name, right? I need to go back to see.
Okay. No, I don't think. Yeah, it's not think
The
you're
object,
using
the object, the reconcile object has a class name.
Okay.
So everything we put to the queue, we patched it. We add a class name to the request. Otherwise, how can
Okay.
we distinguish the tenant?
Okay, let me double check again. Yeah. Okay.
Interesting. So, okay. Okay, so it sounds like there's a couple pieces that we basically need to go through our implementation, see what we would need to push back to make this fully supported. And then I think what we can probably do is let's continue the conversation over the GitHub issue. And maybe what we can do, Wei, is we can work through break it down into individual components that we can add as separate features. So like adding a label that will make it so that the queue won't sync it, or that the informer won't cache it, for example, is one of those pieces. And then we need to.
How can you do that? Informer doesn't cache it. How can you do that?
In your filter functions, just stop calling any of the events on your reconcilers or on your actual controllers if it matches a specific criteria.
Yeah, there is a way to do the filtering, which is that we can put additional filtering.
No, the informer you are talking about is not virtual cluster informer, right?
No, it's the pod informer.
The pod informer?
Yeah. Sorry. In the pod controller, there is basically where you register your your event handlers. You basically add in a label in there.
You want to do that?
Yeah. Because we basically don't want to call any of the pod syncing functions because we don't want it to get in the way of anything else processing if it matches a specific criteria.
Okay, event.
Yeah.
Okay,
Yeah.
I don't know. So one other thing is just performance. Just make sure it will be okay.
Sure.
Seems like you have a lot of logic you need to put there. I don't know. It's very good idea to put in the event handler.
Well, yeah, this one we will see. We haven't implemented anything of that yet, but we can ask. At least you need to sum everything. I mean, you need to. I can double check with the folks who already did that to see if the performance got hit or not. If you don't already did that.
To be clear,
yeah,
we're not saying
he's fine.
We're not saying to add this into the event handler. Into the registration of the event handler is where that calls. There's basically a filter function that will go through, and we currently check to see if it's like a pod or if it's a deletion times.
Every time the reflector got a resource change in an API server, you go through everything before you go to informer, right? You need to go through. No. I think event handler. Oh yeah, before you go to the cache, you go to the event handler first. In the event handler, you need to make sure you want to publish it to the queue or not, right? Or whether you want to push to the cache or not. But in that logic, you are going to do the quota check, if I understand correctly.
No, we're just going to check if there's a label set. We're not going to actually do the check there. Yeah, we're just basically saying use the indexed field that's already in the for a label to check to see if the label's set.
Yeah, then that's okay. I was thinking you are going to do the quota check there. So
no. Quota check is too heavy. Yeah.
Yeah, no. Way later. Yeah. All right. Wait, you and I should try and figure out how we can suss through these as individual features, and then we can bring that back. I think that might help, and then we could potentially show a demo of what this will look like in the long run.
Okay.
Yeah, because Faye, you're absolutely right. There's a lot of places that we can potentially inject a lot of these things as well, so we can continue to look at the long-term strategy for this. Like if it goes to being in the super cluster as an admission webhook, or as a validating webhook rather, what can we do there? How can we inject things back into the tenant control plane so that we could like do the labeling that we need to do? Because that's like the big reason why it's difficult for us to do this at the super clusters admission control, because we don't have the MC controller to basically go and talk back to that individual tenant control plane, for example. So, all right, we'll continue playing on this and filing issues and seeing if we can pull little features out that will make this possible, so we can continue to upstream this.
Yeah, I think I think our takeaway is I think you can do in two places. You think just logic wise, Sync is okay. I mean, silver class webhook definitely should be okay because logical wise you're doing the same thing if you do a serializing the sync as well. So you do
Yeah.
the lock. So just two places in the link, just slightly two different places. I mean, every performance issue you will hit with webhook. I mean, you probably will hit with sync as well because it's again, it's a single, it's centralized thing. Everything goes through that. So
yeah, but the
syncer
sync is
you don't want to make that thing slow anyway.
Right. Yeah, no, absolutely.
Syncer is such a good sweet spot that we really need to do a little bit more development, so benefit from all this structure we have instead of creating totally new one.
I agree. I mean, implementation, the thing is sometimes people choose decouple, although the code look a little bit messy or more, people choose decouple has a reason. Think about it, people, why use microservices instead of monolithic services? Monolithic services is much easier to debug, much easier to write. Why people go with microservices? That's just so hard to debug, so hard to write. In my opinion, there is a reason. So I would suggest think about more about overall architecture wise whether it makes sense or not. So don't think about the implementation in the first place, because even though you use webhook, it just looks complicated, but I don't think it's kind of drastically complicated.
No, in theory, we could technically just use a webhook that was going and saying wherever the request came from, try and go and create a client, go and connect back to the tenant control plane, go and label the pod that's trying to be synced to put it through all of its wakes. And as long as we have that, yeah,
maybe another thing is maybe we can think about it more. So what are the other features you guys want to support? So if you want to use webhook anyways, then maybe why not just add a piece of it? So it's kind of almost
webhook, we have it already, so it's okay. We can compare, but we probably can.
So are you going to move everything? Are you going to? I mean, in theory, you can move everything in the webhook in the syncer. So in theory, you can, because again, it's just a link.
Yeah, but
you make everything serialized and you do the check in the syncer.
Yeah, but the syncer is in yeah. So the syncer, if we extend the syncer to a more generic development platform, it will make a syncer one step up. That not only do the syncer, but give kind of a user a little bit flexibility to develop a little bit more things on top of that, which is also one direction we can explore a little bit instead of using the standard webhook way to do all things. It's at least we have a syncer installed in this stage that probably we can extend.
There's one problem that we haven't solved for as well, which is what happens when we have multiple syncers because we have multiple clusters.
We have multiple syncers, we have multiple clusters, and this is too.
Then we end up in a place where we, yeah. So that's the secondary piece that we still have to visit how we would actually structure that. Don't worry about it right now, though.
Too much. Yeah. I still don't understand how you can make it multiple syncer and multiple cluster. And
now you can. Now multi is just sharding. So you just do
it's just the shard keys.
It's the sharding. You just need to make sure one syncer handles a few tenants. You need to do the sharding. So anyway, so multiple syncers may work. So overall, what I'm trying to say is, okay, you kind of open. I don't know, but the developer are you guys, not end users anyway. So it's you guys, your opinions. It's highly opinionated design. But in very high level is that you have two places you do similar things. Whether you suggest people you open two places, you can do either of one, or you just give a best practice, just use one place.
Yeah, I mean, my ultimate, and going back to some of the conversations that we've had about the multi-tenancy group and its outputs, just kind of diverging for a second there. One of the pieces that I would have loved for us to be able to it's not specific for multi-tenancy, to be clear, but there is a feature that we have never supported within the Cube API service, which is registering admission webhooks behind the scenes, so that we don't have to do compiled in admission controls, because we could just do this at the tenant control plane if we could do that. and we're just trying to avoid forking and mutating the Cube API server for tenants in essence. Because in theory, we could go build this as a compiled in admission control at the tenant control plane, label all of these things at admission lifecycle. Because our biggest stopper for doing it at the tenant control plane through webhooks is that they technically could go through and delete those or have purview into what's there. Because we already have two, for example, because we still have our service cluster IP networking that's funky, and then we have another one that we haven't talked about, but that's separate.
Okay, I agree. So if I were you, I probably pick whatever you guys are doing. If I were you, so but if I was speaking to virtual cluster, I probably will defer a little bit because what if some users just have already webhook implemented, so they simply doesn't need this function. So they say, I mean, I have everything. I have a super already, prepare everything.
Right.
Just Syncer, just do. I mean, I don't need anything to be put in the Syncer.
So we cannot allow everyone put the webhook into the super. This is the key purpose to.
I understand. I mean, you guys definitely know. I'm saying that if any other guys who already have webhook implemented, they are satisfied their use case. They think their webhook is totally fine. So I mean, the Syncer doesn't need to handle any webhook thing. You just do the damn synchronization. That's it.
Okay.
Yeah,
right,
but
this
still, our problem is that if they used to use the webhook, now we have a virtual class on top of that. There was a mess there. We have scenario that it's quite difficult to handle with the virtual cluster if they already had a webhook doing all the batch things, and on top of that,
no,
they never think. Yeah, they never have a virtual class in place.
So here's the thing. So everything that what we're talking about is about capacity planning. So that's the thing that's kind of really difficult from tenant's perspective, because when we build this, this capacity planning thing is they are assuming the endless pool in the super. This is the assumption when we build this, right? Every time you come to hit the capacity planning, which means some of our design is not exactly serverless. This is you have a limitation in the super. Now you need to control the usage. We don't have a good story yet. So if we want to come up with, if we really want to do this, my suggestion won't be open the plugin for doing anything. My suggestion is we just discuss a way to do capacity planning.
Okay. Would you be interested in going down and having that conversation? I know we started that a while ago, but is that something like in terms of making that a piece of VC? Would you be interested in that?
So what I'm saying that if you add a plugin for everything, I don't think that's a good idea. I don't think that's a good idea. But if you are saying that we come up with a solution to do capacity planning, that solution needs a plugin. I think it's okay. So I want to narrow down. I want to narrow down the thing that we provide.
Okay. I totally agree. This plugin, the first plugin should be the capacity planning only, and we can do this specific.
I'm not the first. I'm saying if we want to add a plugin, that plugin should be just capacity planning. I don't want to.
I agree. I totally agree. I think
else.
I think a generic things that you don't know where to plug, and it's a little bit complicated. But plugin for the capacity, we know the exact place and we know how logic.
Yeah, because we know there's a problem. This is a clear definition problem. So we don't have, when we design VC, we don't put the capacity planning because it's too complicated in the first place. But now every people use VC, they need to have their way to handle capacity planning. We do internally, we have our ways to do capacity planning. Not exactly you guys does, but if we want to enhance for this topic, for this very specific topic, I'm okay with it.
Okay.
Because it's clear. I mean, interface is clear. If you don't need capacity planning, just don't use this feature at all. Or, I mean, there's no impact. If you, basically, the question is, if you don't use capacity planning, there's no impact.
Yeah, I agree. Yeah, this is how we use a plugin which can be easily bypassed without any penalty. Yeah. Okay, I have your word. I think this is a good start. Then just planning for very generic things there. We are focusing on the capacity planning now, and we want to do something there.
Yeah, that's okay.
Yeah, good news that I just checked the code. It's the group is per tenant. Even though the group name is confusing, but I thought that this is a group is per kind of a object group name. But now
I'm
is
pretty sure.
cluster name.
I'm pretty sure this thing works because Chow made
Yeah.
experiments in the paper. So otherwise, where did the figure come from?
Cool. All right, we're almost out of time, so I'm going to stop the recording, and then we will all get together next week. Again, I'll send Charles and Faye, both of you, probably some pull requests in the next day or so for releasing virtual cluster images.
Yeah, just send me a piece of code for the dynamic client. So if you have sample code already.
Okay. I'll look through the art history as well in Google Docs and see if I can find Vince's recording.
So do you have a real sample? I mean, just pull me a real sample.
Oh, it's there. Yeah, we can give you. Yeah.
Okay.
Yeah, just pull me a real sample. So I want to see the difference that I want to see if I want to push to do this in our internal things.
Okay.
Sounds good.
Okay.
All right, folks. Thanks everybody, and this video will be posted to YouTube.
Chris,
Oh, hey, Charles.
Yeah. Hi. Wait. Also, I got one more question. So, when you're talking about a resource quota, you just consider about the computing resource, or you also, because the default resource quota allow us to consider some other resource, like if my
We're talking
memory is
CPU,
correct,
memory,
there's something
and
like
GPUs.
correct. Oh,
Yeah.
okay.
We're not talking about
because
pods or any services or anything like that.
I think the resource quota can
Yeah.
also control the number of pods, right? If
Yeah,
I-
I did put in there. I did put in there. We can add anything you like in the CRD. Then we can check, aggregate all these things. This is up to you to do the logic in the logic. Yeah.
I see. Yeah, because I'm working on another something like a cross namespace resource quota things. May not directly related to the VC resource quota, but I'm working on a more generic plugin can use on any Kubernetes cluster, and I found it's really hard to just using a webhook and a controller to implement the logic. So yeah, so I would like to see like what's our solution for VC, and maybe I can borrow some idea. Yeah.
If you like, I can push you back into this group that discuss the batch things. If you like.
Yeah, sure. Yeah.
We have some
that'll be
meetings
great.
sometime. Yeah. Okay. I will put into the WeChat. Yeah.
Okay. All right. Thank you.
Okay. See you.
All right, thanks everybody.